Resolving vectors. If we have a 3-meter displacement vector in this direction, followed by a 4-meter displacement vector in this direction, we can find the resultant using Pythagoras as a 5-meter displacement vector in this direction. We could find the angles involved using sine, cosine and tangent. Often we want to do the reverse process of finding the vectors in two perpendicular directions of this, say, 5-meter vector. To find the vector in the horizontal direction, I've put a baseline here. We'd be given this angle theta generally in the question, and we want to find the horizontal vector x. We know that cosine of theta will be adjacent over hypotenuse, which in this case is x over 5, and so x, rearranging the equation, is equal to 5 cos theta. To find the vertical component of the displacement, y here, well, sine of theta will equal opposite over hypotenuse, which is y over 5. So rearranging, y equals 5 sine theta. The calculation works just the same if we draw the vertical vector in this position, starting from the same point as the horizontal vector. This is often more appropriate, particularly when we have several forces acting on a body. In a more general case, if we have a vector v and we want to find the horizontal component going across an angle theta, like this, well, the horizontal component will be v cos theta. The vertical component v sine theta. Looking at another case, we have the same vector v here, but now we're given the angle to the vertical, which I've called alpha. If we want to find the vertical component, it will be v cos alpha. Remember, in the previous case where we had the horizontal angle, this became v sine theta. The horizontal component will be v sine alpha. In the previous case where we were given this angle, it was v cos alpha. So, if we're resolving a vector across the given angle, we multiply by the cosine of the angle. So here we're moving the vector across the angle alpha, and we get v cos alpha. And if we're resolving a vector away from the given angle, we multiply by the sine of the angle. Let's just look at a simple example. A football is kicked with a velocity of 23 meters per second at an angle of 32 degrees to the ground. Calculate the vertical and horizontal components of its velocity. Well, a diagram is essential for a problem like this, and try to draw it roughly to scale. It just helps you visualize the problem and also gives you a quick check of accuracy at the end. So, we have a vector of 23 meters per second at 32 degrees to the horizontal. The horizontal component, indicated by an arrow here, you'll see I have my arrow coming directly below this one, will be across the angle, so it is 23 cos 32 degrees, which gives an answer of 19.5 meters per second, which seems roughly correct. The vertical component here is going away from the angle, so that will be 23 sine 32 degrees, which gives an answer of 12.2 meters per second, which again seems roughly correct.